In this video, I'll be discussing how to read the square and square root, the square root tables that will be provided to you when you are solving your sums in your examinations. These tables are also there at the back of your textbook, so if you guys want to have a look at it, it's there. So this is what it looks like. The first two pages are basically square roots from 1 to 10. This is here on the screen, as you can see, is the first page. It has the square roots going from all the way from 1, 1.2, 1.3, moving till 5.9 on the first page. This is the first page of your book of the pages that we have. This is the second page, which goes from all the way from 6 till 9.9, I believe. Yeah. So the first two pages are square roots from 1 to 10. The pages after that, we've got the square roots from 10 to 100. The next page has the square roots from all the way from 10 up till the square root of 59 down here, right? And then on the page after that, we've got square roots from, where is the exit? Yeah, we've got square roots from 60 all the way up to 99, right? So we'll just take a few examples and we'll discuss how to find the square roots using these tables. Now, if you notice one thing, we've got a bunch of integer values on the left hand side over here. On the first column on the left, 60, 61, 62, 63, 64, right? We've got a bunch of numbers here as well, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9 on top, and then you have this bunch of this entire group of columns called as the mean difference columns. I'll tell you how to use each one of them at the moment. Yeah. So now let's just use this table right now. Suppose if I ask you, I want to find the square root of say 73. I want to find square root of 73, right? This is what I want to do. Let's write on this. Oh, sorry. Let's write it on this side. I want to find the value of square root 73. Okay, so you will search for 73 on the very first column. If you see, we have 73 over here, this here, right? Now the value right next to it, which is this 0, yeah, so 0, 7. So these are all the decimal values. Okay, so if I say 73, this is 73.0, which is this here, 8.544. 8.544. That's it, just as straightforward as that. Yeah. Suppose if I had to find the square root of for any reason 73.4, right? Then I would see, okay, this is the column for 73. This is the row of 73 over here. This entire row is dealing with the value, the square root of 73 values. And if I want 73.4, I'll look at this. So this is 73.0, 73.1, 73.2, 3, 4. So this is the column I would like to look at. This is a 73.4 column. Now where these two lines intersect this value here. So that means this is the square root of 73.4, 8.567, right? 73.4. Suppose if I had two decimal values, if I had to find the square root of 73.48, suppose, yeah. So we've already found the value for 73.4. This is the one, 8.567. Now this 8 which is left, this value for to adjust for this value of 8 which comes afterwards, you'll have to look at the mean differences column. So 73.4 is 8.567. Let's write it here, 8.567, right? And we'll have to add this value that we get for the mean difference, which is over here, the mean difference column. So the value for 8, yeah, this value here for 8, which is 5. So we'll have to add 0.005 to this value, right? So the square root of 73.48 is 8.572. This will be the value for square root of 73.58. I hope that makes sense. It's quite easy finding the square root of whole numbers or integer values. It's just 73, the value right next. Suppose if I'm talking about 63, right? The square root of 63. Square root of 63 will be 7.937. Yeah. If I want 63.8, 63.8, so this is 63 here, and 63.8 will be 7.987. Yeah, this will be the square root of 63.8. This here, which I'm writing right now, is 63.8. And suppose if I want to find the value for 63.84, right? 63.84. I already have 63.8 as 7.987, and 4, I'll check the mean difference value here, which is 3. So plus 0.003, I'll add these two values, right? So that is going to give me 0.997. The 7.99, this value here is the square root of 63.84, right? Okay, so that was for if I had to find for any value between 10 and 100, I would use one of these two tables and I would find them accordingly. Let's take a glance at values between 1 and 10. Suppose if I had to find something here. So if I had to find the value of square root, which table is this? Suppose if I had to find the value for square root 6.1, I can directly take it from here. 6.1 is here. Square root of that will be 2.470, and the remaining procedure. And so if I had to take 6.12, right? So 6.1 is here. 6.12 will be this 2.474. Just have to read it from the table directly. It's really straightforward, right? So this was for two-digit number, like numbers between 1 and 100, basically. Sometimes, very rarely though, but sometimes we do end up getting numbers which are above 100 as well in our sums. Very rarely, but we do sometimes get that. Suppose if let's take an example for that as well, right? So suppose if I get a question, let's use this table here. Don't need you, we'll stick to you. Yeah. Suppose if I want to find the square root of 108, right? Okay. Now you have two options. Sorry. Suppose I want to find the value of square root of 108. What I can do is I can factorize this number, right? So this is actually, if you factorize it and see, it's basically 36 into 3, right? And 36, as we know, is the square of 6. So this can be written as 6 root 3. So all I need to do is I have the value of 6. The value of root 3 I can find from the table, which is, if you can see, it is, oh sorry, went to, yeah, value of root 3 is 1.732. I want to use that value. Where did the calculation go? Here. Into 1.732. Right? So 6 into 1.732, if I calculate that, I get the value of square root of 108. Now that is one way of solving it. Other way could be, so in this situation, I could factorize 108 and I could get the values out of it. But what if I get a number which can't be factorized, which cannot be factorized as easily, or maybe it's a prime number, right? Suppose if I get something that is like square root of, let's see, 243. No, not 240. Let's take 247. Yeah. Square root of 247. Right now, not easy to factorize. I'm not sure. Maybe it may even be a prime number. I'm not quite sure. But then, yeah, if you have something like this, a 3-digit number which is large and cannot be easily factorized, what you can do is you can consider this number to be 2.47 into 100. Right now, we can find the square. We know the square root of 100 is just 10. So this becomes 10 into the square root of 2.47. And the value of the square root of 2.47 is what we take from the table. Okay, so 2.47, we have 2.4 over here. 2.47 will be this value under the 7 column. This is 2.4 and this is 7. So 2.47 is 1.572. So this becomes 10 into 1.572, which is basically 15.72. That's the value for the square root of square root of 247. Let's take another example similar to this one. Let's say we have a number 150, let's say 173, Yeah, let's see if you want to find the square root of 173, right? Once again, if you can factorize this, well and good, but if you can't, right, you can consider this to be square root of 1.73 into 100, right? All we've done is we've written 173 as 1.73 into 100. Now the square root of 100 is 10, and what we'll do is we'll find the value of 1.73, the square root of 1.73 from the given table. Square root of 1.73, so we have 1.7 over here, and 1.73 will be this value here under the 3 column, right? So 1.73 will be 1.315. 1.315. This becomes 13.15, right? So this is how we use the tables, the square root tables. Hope this helps for solving the sums where we need to use the quadratic formula.